All right, it is 4 after the hour. We're up to 25 participants now. So Paul, I'm going to hand things over to you.
Okay. All right. I think my screen is shared and I hope everyone can hear me.
Yep,
My name is Paul Rodriguez. I work at SDSC. I'm going to talk about a project that is a humanities project, and it's called the Morelli Machine. And we're working with a couple of art historians at the University of Pittsburgh on this. Let me go to my next slide. Okay, so I'm not going to read the whole abstract. Let me just summarize the abstract in the next slide. So the motivations for this is that the historians are interested in algorithmic approach to stylistic elements, and I should do a little bit of just sort of background. You know, I've never worked with art historians. I have worked with one of these in the last project, in a recent project, but prior to that, I've never worked with art historians. And it's surprising that, or perhaps maybe some of you know that nowadays digital humanities is a growing thing, and people are really interested in using computers and of course using machine learning algorithms and thinking about their topic in new ways. And so the historians are, they're quite savvy, and they had some ideas, and they've come across different kinds of research, so they were interested in this idea of looking at algorithmic approaches for styles, looking at both whole images and certain kinds of details. The Morelli machine is an idea that was proposed in the late 1800s by a person named Morelli, who said, look, you can look at authorship by comparing fine details of a painting, how someone might paint a hand or an ear. And of course, he didn't actually identify what counts as, a style, but that was his proposal. And it does that proposal itself apparently isn't a big deal in art history these days. It's not like it was an idea that people threw around a lot, I guess, a while ago, but the idea behind it, the idea that you can somehow come up with an algorithm, that was important for these art historians. So we wanted to apply some computer vision techniques, and particularly, convolution networks are something that people in the humanities come across. So our goal here was so the way I interpreted this, or the way I took their information and made it into concrete goals, I said, well, we want to be able to discriminate paintings and face parts in those paintings with the kind of features useful in computer vision, analyze the features and show groupings of those features based on, let's say, clustering for these historical paintings. So when we talk about computer vision techniques for object discrimination, they rely either on predetermined features or feature discovery. So predetermined features are things like edge detectors, histogram of gradients. You're looking at how pixel intensity changes in directions, and entropy. And before convolution networks came about, these were the features that people were using, in the early 2000s for object recognition. And they were doing pretty good with face detection and face, I don't know about face recognition, but face detection for sure, and lots of other kinds of object detection. But it wasn't, large scale stuff. It wasn't doing as great as it could have in the convolution networks that started coming about in the last, I guess, 6, 7, 8 years, have really, changed or really made some big advances in computer vision. Which is not to say that the other kinds of features aren't necessarily useful. But nowadays, of course, everyone's looking at convolution networks, and these are things that do feature discovery. And it's generally thought of, or generally intuitive that the lower layers of a convolution network tend to reflect texture, color, maybe intensity variations. These are typically convolution networks where your lower layers have very small filter sizes, excuse me. The higher layers tend to reflect more object-like features. So typically you're training these networks to do some kind of object classification. And so naturally the higher layers are going to reflect larger scale kinds of features. And of course, nowadays there are several kinds of pre-trained networks that have been run on these large-scale vision competitions. And the one I am looking at is called the VGG19, which a visual group, I can't remember what the VGG stands for, but it's a group from Oxford. And they've had a couple variations on this convolution network, and it's been out for a while, and people have used this for other kinds of things. And they have some pre-trained networks available in the convolution network software packages. So, and it looks something like this. It has kind of 5 sets of layers. There's really, if you look at each box, there's more than just 5 layers, but there's 5 layers where there's max pooling going on. And so I want to pull out the layer of activation. So I want to run these images through the network and pull out the activations from these 5 layers. Okay. And so what I've listed here is the 5 layers and the size of those layers. Excuse me again. Okay. So and just to reiterate that, you know, these are a lot of let's say features. So this is 64 maps of 112 by 112 is each map. So the original image gets transformed as you go through each of these layers, and they get downsized. And so typically in these convolution networks, the images are downsized, but the number of channels goes up. So we start out with a 224 by 224 image, and at the end you have a 7 by 7 map that summarizes those images, but you have 512 of those maps. And so the question is, which convolution layer should we use? Well, the research that looks at ways of using convolution networks for masking shows that, you know, it's very useful to have all the layers if you're trying to pick out fine detail. So given that we're not really sure if we're looking for fine detail, we're not sure if we're just looking for high level, abstract categories, we're going to look at all the layers. Okay. And so let me give you a sample of what some of the images look like. So these are all high resolution images. They actually come from different collections, but there's one group called CRESS, and I don't remember what their full name is, but there's a board that runs this based in New York, and they kind of have like access to these images. And these aren't necessarily famous. Well, some of these are famous images. I guess if you're an art historian, they're all famous. But the images were digitized, I think, for different people or different ways. So there's quite a variety. There's actually, I think this is actually 3 collections of digital images put together, sort of in one. We put them together in one big group. And so most of the images don't have a frame, but a lot of images do have frames. And when they have a frame, it's quite varied. So sometimes the frame is, quite ornate. Sometimes the frame is, there's one picture in here in the middle where there's actually 2 images that are surrounded by a frame. Some of these are religious paintings that were done in I'm not sure what years, but they were painted and put in a frame to be displayed a certain way. Some of the frames are just unusual shapes. So we have these pointy frames, rounded frames, and circle. There's a lot of frames with circles. And so we had this kind of challenge, is that we wanted to, for these convolution networks, we wanted to pre-process the images and you have to pull out some kind of square part of the image. Okay, so we had to redo some resizing and cropping in some combination. And at first, when I did this, I just picked out what looked like reasonable resizings and croppings, and most of the images seemed like they did pretty well. But then I realized that there were enough images with frames, unusual frames, that we really had to start doing this a little bit more manually. The PIs went through and they sorted the images, which according to the frame types. So then we had sort of subsets, and we could deal with that more directly. And so for each image, I didn't want to go through and manually segment out a square, because that would actually be pretty hard, as I'll show you in a second. And it would also be time consuming. So what I did is I took what seemed to be 4 possible resizes and 3 possible croppings. So I combined those together and did 12 possible variations in the image. So my pre-processing steps took these 12 different combinations, and then I just went by hand and selected which combination seems to be the best trade-off between cutting out frames and leaving the main parts of the image. And the reason we wanted to cut out frames is if we don't cut out frames, it turns out to be a really dominating feature for the convolution networks and for the edge detector kinds of analysis. Okay, so what I'm showing you here is the 12 different resizes and croppings. The third row, second column seemed to me like the best trade-off, so there's a little bit of subjectivity here. But you know what, with a lot of these images, even if I sat there for hours, you really, it's so hard to pick out the exact kind of 224 by 224 square that would be perfect. There's really, it's a little bit of, you know, like I said, it's a manual process and there's a little bit of subjectivity, but I think even, I don't know if we could automate it much better. Okay, so I did that. And a few images were just, you know, there were even some frames that were triangular, and there's really like no way to get a little square out of that really captures the image, I think. So I threw out some images. And then I ran these through the network. And I had this other question. I had, for each feature map, there, you know, so for example, the first layer is 64 maps, 112 by 112. The last layer was 512 maps, 7 by 7. That's, I wanted to summarize this in a way. Now, in order to do dimension reduction, what a lot of people would do is just combine all these feature maps into a giant vector and then do maybe dimension reduction on that. But I didn't want to lose what each feature map have. And that's because some intuitions, and some people talk about this in their, when they talk about deep learning, is that each feature map is somehow detecting the presence of, let's say, something in the image. And presumably or intuitively, a good convolution network will have feature maps that are somewhat independent or somewhat uncorrelated. They're all, you know, processing different features. Now, the map itself still maintains some spatial information. But what I did is I said, well, let's assume that each feature map is just about the presence of something, and let's just summarize it by taking the norm of the matrix, or really just the total activation of that feature map. So I took the 512 7 by 7 and I reduced it to 512 values. And then I used a k-means clustering. I'm not going to say too much. I mean, I did just the standard k-means. You know, with k-means, there was this question of how do you choose the best k. Typically, you know, I ran a couple tests, and so I knew I'd had at least 4 clusters that were very well defined, and then somehow. So that's a silhouette test. A different test showed that maybe I had like 20 clusters. So somewhere in that range, you know, between 4 and 20, that's a big range. So what I did was I ran a hierarchical clustering. I compared this, I ran this with the PIs. We did some evaluation. We looked at it and we said, okay, let's select a reasonable K. So we selected 16 as a reasonable grouping. I'm showing you the dendrogram for the hierarchical clustering. So you can look at 16, which is a cutoff right around 1,000 on the vertical axis. And that gives you a sense of, you know, if you're familiar with hierarchical clustering, the dendrogram gives you a sense of how well those 16 clusters are defined. And you can see that the vertical distance between when things are joined starts getting small right around 16. So 16 we selected as a reasonable number, and here's an example of what those clusters look like. So on the left is one cluster, the right is another cluster, and I'm showing you the original images. I'm sorry, the original images with the frames before any cropping or resize as thumbnails. So you can see that cluster 1, the original images come in all different shapes and sizes, and cluster 2, they're more similar in size, but they're also different shapes. So the frame elements, it's still a lot of images where there's still like bits of frame perhaps in there, but they don't really dominate anymore. Here's all 16 clusters. It's a lot to look at. I'm not going to say too much about that, but they all look pretty reasonable. You know, faces, portraits come together. Portraits tend to cluster together. There's a cluster in the second row, the leftmost column, which is, landscapes. So it's all doing a kind of a reasonable job. And I wanted to go, and after that, I wanted to look at the features more directly. So the question is, one question is, do the summary features really capture the data? Okay, so here's an analysis where I compared the summary features I did with the full feature maps. And I just ran some principal components, and I'm not going to go through the details, but the summary matrix, it does maintain a lot of the information that is in feature maps, and it reduces dimension. It does lose some of the variance. So we're losing spatial information. So the kind of analysis, so this kind of summary that I'm doing may not be appropriate. It may not reflect everything that a network does for object recognition, but it does have a lot of information still. Okay, so one way to evaluate features is to say, well, does feature help discriminate between any pair of clusters? So I ran a bunch of t-tests where I compared every cluster to every other cluster. And for each feature, I said, well, does each feature have at least one or pair of clusters that it helps discriminate? And all the features, almost all features, have some discriminatory information, even when you run t-tests and you look at really small p-values. And so if you look back, and it kind of makes sense because some of these clusters of images were pretty distinct. So we can also ask, well, which features are most discriminatory for each cluster? So this is a standard kind of thing we do at k-means clustering. So for each pair of clusters, I looked at all the p-values for features that help discriminate that cluster with another cluster. I looked at the most discriminating features, and they all come from the top layers, 3, 4, and 5. So this implies that clustering is based on the feature combinations that are most relevant for object recognition. Another way to think of that is that the images do have salient objects or object-like items. Okay. And if we look at the classification labels, there's actually a lot of overlap. So for example, those two clusters I showed before, the vestment class. So these, remember, this is a network trained to recognize 1,000 objects. One of them was something called vestment. There's also cloak, book jacket, altar, throne. Those are also prominent kinds of objects that get classified, or they get predicted out of these images. And what I'm showing you here, the numbers are the average prediction over all the elements in a cluster. So not every image might have a strong vestment prediction, but across 85 images in cluster 1, the average prediction value for vestment was 13. That means some of them are predicting vestment very strong, and some of them maybe not so strong. Some of them might be predicting, cloak or book jacket very strong, and less so for the other ones. Okay. Okay. So I wanted to also run a comparison with the predetermined features. So again, I extracted these different kind of edge detectors, histogram gradients. So they lose spatial information because I summarized them. In reality, when you do an edge detector, you actually have a map of edges. So, but I'm losing the spatial information for the comparison purposes. And I find that histogram gradients is correlated with the higher convolution network layers. So that suggests histogram gradients is also capturing some more abstract combination of features, of lower level features. Edges and entropy are more correlated with the lower layers. And that can be, the average correlation level is relatively higher, 0.5, for example. So that means that the lower layers really are capturing something about edges, or maybe, texture. And then within convolution layers, there is a lot of correlations. But as you get to layer 5, those correlations become more distinct, the correlations become much lower, so the features are probably something more distinct. Between layers, there is a lot of correlation of features between, let's say, layer 1 and layer 2 and layer 3, but as you go up to layer 4 and layer 5, it becomes less. Okay, so in some sense, that might be intuitive. So I wanted to say, well, what if we cluster everything just using layer 1 by itself? So again, you do get pretty reasonable clusters, but there is a little bit more variation. And we do see, for example, we do see if we zoom in on, here's a cluster that wasn't a cluster before when I used all the layers, but if I just use layer 1, I do get a cluster of these images, which are, you know, they're, if you look, I mean, obviously they're just, it's a very distinct kind of painting, and the color is very prominent, you know, distinct, and the texture seems to be distinct. So these images, I'm not sure where they clustered in the previous clustering analysis. They might have been part of a different cluster, but here they're clustered separately. So cluster layer 1 is, you know, giving you a different set of clusters. There's a lot of overlap between this one and the previous clustering, but there's enough also distinction so that maybe you could pull out interesting combinations of images that, you know, reflect some, let's say, I don't want to say stylistic element, but, you know, some feature. Okay, just real quick, I also did some other visualizations using TS&E plot, so maybe some people have tried this. These can be very useful. You can zoom in. It's more useful if you have some interactive means to zoom in. This is like a multi-dimensional scaling, so you can see things in 2 dimensions. We didn't use this a lot, but you know, it's the kind of thing that I think could be useful in some situations. And I also said, well, what if we, instead of basing our analysis based on clusters, what if we look at features and imagine that each feature is doing something that's stylistic? So I took all the features, I normalized their activity by the mean and standard deviation across images. I took features with highest outliers, and I gathered those images that are outliers in that feature. So for example, here's a feature, and it has, it's from layer 4. It had some relatively big outliers, and it was most active for the following images. So the top row are the outliers for this feature. And these are not all in the same cluster in the final analysis, but if you just said, well, what does this feature do, and, you know, what are the elements of an image that, let's say, are distinct according to this feature? And so here I show you the top row with the most outliers, and of course the 2 on the far left were most extreme. So it looks like, you know, it's hard to say, but it looks like there's some, you know, feature of a yellowish whitish spot, or some shade of yellow or white that seems to be important. And we can run. So one thing I haven't done, I'll mention later, is that there are ways to look at convolution networks and run what's called like a heat map of activation to see what is it of an image that is really activating this feature. So we could play this kind of analysis where we look at features, we look at clusters and see what's important for a cluster, or we look at features and see what kind of images are important for that feature. And then run this kind of heat map and analysis to see what part of an image is actually the important thing. So I'm going to run that. I think I haven't run that yet, but I'm going to do that, and then I can compare. You know, I compare features directly. And I just want to mention, the PI. So we also have the output that came out of this is we have a spreadsheet that looks at the cluster ID. It looks at, you know, within cluster distances and with between cluster distances for each image. So we can do an analysis where we sort through things. I'm running out of time, but I want to talk quickly about the face parts. So we were also interested in analyzing parts of face. So I ran things with I compared different face detection algorithms, and the Google Vision has an API that will extract faces for you, and that was working better than some of the OpenCV stuff. And the nice thing is you get these landmarks. It tells you where certain points are in the eyes, nose, and mouth. So I was able to run the Google Vision, get the landmarks, pull out regions around the eyes, mouth, and nose, so I can extract those. Now, Google Vision API will give you an estimate of whether or not a face is turned a little bit. And what I find is that if the face is not turned too much, those estimates can be pretty good, and you can use that to help modify how much you extract around the eye and the mouth and the nose. So as long as those estimates aren't too, as long as the face is not a profile, this works pretty well. When the face becomes more of a profile, it's harder to extract an eye when it's half the eye is invisible, is occluded by a face being turned. Okay, and I started with the mouths. The mouths were actually the easiest thing to cluster because the mouths were the easiest thing to extract. There was the landmarking worked very well for that. So, but the problem is there was a lot of small mouths, and I did a clustering where I upsized the mouths, and to get it to be 224 by 224. And so this is what the clusterings look like. I'm not going to go into detail of this. It's really, this didn't really come out with any prominent, let's say, other than the color and texture. There wasn't a lot of prominent landmarks or features you could look at and say, oh, these mouths are turned one way. These mouths are, they all have like a little curl on the lip. So this didn't come out with anything like that. And I did both clustering with all the layers and a clustering with just layer one. So layer one clustering is even more prominently showing different colors and textures, I think. We also looked at applying this to hands. And hands is a different, so I have several slides on this. I'm just going to cut through the chase. But the hand extraction is a lot harder. And this comes out of the, so there's some examples in the convolution networks of building networks that help you extract where objects are. So, and it'll give you a box. And that takes like a little extra, well, I shouldn't say little, it takes like a separate part of a convolution network to produce predictions of where the box are. And these run, they actually take a little bit longer to run because you have to propose certain regions, you try out certain regions, there's a certain different kind of pooling. And you end up though with bounding box information that gives you a box center, a location in the image, and the height and the width. So this is what's getting predicted besides the classification. And there was a data set that came from somebody a few years ago. Before they were doing convolution networks. So I tried to gather up information. So not only did they have the hands, but then I ran a face detector and a person detector. And I said, well, look, I have persons in a box, the face and the hand. Maybe I could use that together. I trained one of these regional convolution networks. And you can see on this data set, it does okay. It gets some hands. It also gets other body parts. So it was running about 50% true positive rate. But I didn't. But that really wasn't quite enough to run with the art images. The art images are, a lot of the hands are even more occluded. So I didn't use this method. But it turns out that Facebook has a recent tool called a recent set of networks that they call detectron networks. And they will also not only detect persons and segment persons, but they'll also detect parts, the key points of a person. So on the far right, I don't know if you can see, but there is a person with these lines drawn where their knees are, their ankles, their elbows, their shoulder, and their wrist, as well as the other shoulders. And I think there's some face information. So I took that network and I ran it on some images.
Excuse me, Paul, this is Bob. Do you mind if I chime in real quick? We're at 10:32, and I know we started a couple minutes late, but if you could finish soon so that we have time for a minute, and we have a couple of questions queued up.
Okay, I'm in my last few slides. So I started running this. This turned out to be really hard for these art images because, when people are wearing these kinds of clothes, it really doesn't get the elbow right. It doesn't get the wrist right. Hands are occluded. So this was a part of the project that I kind of pushed to the side and stopped at that point. I'm not really sure if we're going to go back to that. Okay, so just finally, I did take these clusters from the whole image analysis, and I said, well, what if we ran it with a classifier, and that'll help us pick out which features are important. It turns out that about half the features that are important for clustering are also important for classification. So I might be able to just run an analysis that focuses on those features, for example. And then there's some other things I looked at and I'm thinking about. So there is a tool that Ilya has here called Suave for sorting through thumbnails, and these are probably other things that I'm not, we might also cluster the eyes and nose, but these are further down the list, I think. Okay, so just a summary. In terms of computation, definitely, if you're doing any training with CNNs, you got to use GPUs. But if you're just extracting layers, I found that I was able to use single node CPUs and, not have to wait too long. The question of features and style, it's still a subjective thing. But I think now, I think art historians are happy that at least we can start looking at these computer visual elements and talk about that. And I do think that CNNs, they open up a lot of possible questions and avenues for different domains. And I think that was the other, one of the other things we want to get out of this. Okay, I'm going to stop there.
All right, great. Thank you, Paul. We have a question first from Sergio. Sergio, do you want to go ahead and ask?
Yeah, so Paul, so I guess you alluded to that in the last, at the end, but what do our friends, the art historians, actually think of progress that has been achieved? Is it heartening to them, or?
Well, I tell you what, when we started this, we started this thinking about the Morelli hypothesis, and when they talked to me about it, I always talked about it in terms of feature analysis. And as we went through, we found that the hands were hard, but that mouths were pretty good, and eyes and nose were pretty good, and they got interested in the whole images. So they remember that I should step back one. Let me step back. And there was two things when we started. They were interested in the Morelli machine, but they were also interested in looking at convolution networks and what that could do. So as we got to the point where we were, and I started out with just the simple features. I actually started this kind of in the reverse of this talk I just gave. I started out talking about edge detectors and things like that. So I wanted them to be thinking about features. And as we went to the whole images and started doing clusterings, and they could see like, oh, wow, these are really interesting kinds of ways to, group a set of pictures, think about what it is that the computer is actually seeing. So they got interested in thinking about it that way. What is it that a computer sees that maybe the humans don't see or don't see in the same way? Mm-hmm. And that for them became more interesting than the Morelli machine hypothesis. Whether or not you could, distinguish an author by looking at the fine grains of a hand.
Right.
So it's not, maybe I shouldn't say it's more interesting, but it became more relevant perhaps. So they got interested in that, and that's what they talk about now.
Okay. And then I was also wondering, like in terms of testing the hypothesis itself, that
Sergio, actually, I'm sorry, we ran a little over, and I want to make sure that that Amit has time for his presentation. But if you want to follow up on this through the chat, and similarly, Mona.
Well, Paul, you can just read what I wrote in the chat. So.
Okay.
All right, great. Thank you, Paul. That was excellent, fantastic project. So Amit, go ahead and share, and we're going to let you run a few minutes past the hour. I know we have a bunch of folks on who are very interested in the topic and the gateway reporting.
Perfect. All right. So let's see. Okay.
Everyone else, please remind to mute.
My slides look okay?
Looks good.
Okay, perfect. All right, so I'm going to be talking about this improving science gateways usage reporting for XSEDE, which I've been spearheading with quite a few folks, and Scott Sakai, Michael Shapiro, and Stephen Gallo we've been having kind of a very cohesive kind of a way of kind of getting this in place. And then XEI was also involved in this thing. So there's only one URL which you need to know if you're a gateway operator, and that's the one which is noted at the bottom. So for folks who do not know what this is about, When somebody runs a job on a system, the service providers, aka the cluster operators, will report to XSEDE that who ran the job, how much usage the job incurred, and which allocation it belonged to XSEDE. When gateways run any job on XSEDE resources, they run as community account and not as an account which a gateway user's account. So the clusters don't have any visibility on what the gateway users are and what kind of computation is happening on their behalf, because the gateways just operate via a community account on XSEDE resources. So the gateway attributes is a way to provide this complementary information about the compute jobs that were kind of run on a cluster on a community account. Essentially, they report whom the job was run for on a cluster, because the SPs or the cluster do not know for whom this job was computed. And XSEDE mandates that the gateway should report this information to XSEDE. And so this effort was originally undertaken during the TeraGrid days. So it's been there, it works, but it's sort of dated, and it needed an update to kind of handle things in a better way. So this is what happens when a gateway runs a job on a compute cluster. The service provider will report the job ID, which would be the Slurm, yes, or whatever scheduler ID that the cluster provides. It would provide the username, who actually is the gateway operator who runs the job for the gateway users, and then how much use it incurred and what allocation it was, and node information and so forth. This gets reported via AMI packets, if you guys are familiar with that, as NPUs to XDCDB, which is the XSEDE central database. Then the gateways come in and they say, oh, by the way, this job which we ran on a cluster with this job ID was for my gateway and for this particular user. And when that information reaches to XDCDB or XSEDE central database, it gets combined based on the job ID, which should match. And then we have a better record of this thing from both sides on who ran the job and actually whom it ran for in reality. The importance of this thing is that since the XSEDE or service providers don't really have any visibility about who's actually using the system, the attributes provide that information to us. So once these attributes are available and reported, a SP can find out how many gateway users are actually using a system, or how many jobs were being submitted for a particular gateway user. And then they can better understand how the gateways are using their cluster. And then, lastly, they want to report all this information to the sponsor. From an XSEDE point of view, they want to do all the same things as the SPs, but they also want to know how the various clusters are being used to meet various needs of the community. And then again, get a better visibility of the breadth of users that are using XSEDE resources. So here is a chart of XSEDE users over time. This is not current, but until 2017. I think there are only two lines to kind of quickly take a peek at, the orange and the red. The red line indicates the active HPC users, and the orange line indicates the active gateway users. So there is a fourfold or fivefold difference between the number of gateway users and HPC users. So this is a important area for XSEDE and SPs to track and see how wide the community is and how they are using the available resources. So gateways are quite popular on XSEDE, and that's not surprising. So what was the shortcoming of the existing method? There were quite a few actually, and this goes on to the way originally the reporting was developed and the way it's implemented. And it worked well for a large period of time. However, it was time to kind of update this, and this problem has been lingering for some time, and it needed to be solved. So earlier, there were two ways to report this information. One by directly writing to the database, which is, we don't want to absolutely do that. And then the other way was to use web services, which was also implemented with two different submission scripts. And then there were other issues with those things as well. So these scripts were installed by the XSEDE service providers, and they would manage it, they would document it, and they were used by the gateways. Once somebody was on a system and reported something, the submission was sort of went on behalf of the service provider. So all gateways using a particular resource would show up as if the service provider submitted the attributes, which is sort of true, but there was no visibility on who actually submitted something. So if somebody decided to kind of, pollute the database, it would be pretty hard to track that down. For the gateway operators, there were several issues. The submission methods for each SPs varied, and the gateways must know this. Furthermore, the gateways attributes could only be submitted from login nodes, and that created problems of when things were running on GPUs, for instance, and they were supposed to be reported as separate resources. There was very little data validation and consistency checks that were being done on the server side. So whatever the gateways decided to put in, it went in. The quality of the data was not as high as we'd like. And then the gateway operators had to just figure it out all by themselves, as the APIs did not really provide any feedback on whether they are submitting the right thing or not. So they had to kind of figure this all out on their own. And then if they wanted to see what was submitted, they have to go and submit a ticket for someone to track all that stuff down and report it to them, how things were actually being submitted and reported. So lots of bits and pieces which need to be put together, and quite burdensome for the gateway operators. So what we decided to do was we needed to make refinements for all parties. So first thing which we did was look at the server side and figure out what the gateways need, and develop a system that matches what the gateways are actually submitting. And then once the gateway submits something, we check for things where we can, and make sure that the data is being received and processed in a consistent manner, and then recorded into the database. And lastly, if things were not being submitted as, because we were doing all these consistency checks, we could report back to the gateway operator saying that, there is something off here, this needs to be fixed. So all this can be done fairly easily. And once we knew what, needed to be done on the server side, that's what actually ended up in the design. And we decided that we will make this as easy as possible for the gateway operators, because ultimately the burden of submitting this reporting is on them. And we wanted to make this as easy as possible for them. So the first idea was to make everything where possible self-service. So avoid ticketing altogether, so that everything can happen very quickly, and then tickets are for special purposes. There is a single documentation for submission for any XSEDE resource now. Earlier there were, each SP had a different documentation. And there were many other, internal things that the XSEDE gateway operator needed to know. So the idea was that let's not burden the gateway operator with all that. Let's hide all that stuff and keep the internals to ourselves. And lastly, let's not depend on other scripts to make these submissions, and make the submission tool agnostic. So the gateway operator can integrate this in their favorite languages or whatever their tool chain is, and make this work much more smoothly for them. And then Furthermore, we wanted to kind of eliminate the hassle for SPs to kind of manage and broker all this submission setup, and then the gateways can take care of this themselves much more easily, because it's them who will be submitting these attributes anyways. And then from the get-go, we wanted to have a very good integration with XDMod, because this data eventually will show up on XDMod. And the idea is when it shows up there, the community has a better view of what is going on with gateways individually or in collection. So they were plugged in from the get-go and had a voice and kind of saying that, hey, this would make things much better. These are the things which are useful. So the implementation is a new REST interface, which allows a gateway to register their gateway through at one spot using XSEDE single sign-on. No more ticketing there. Each gateway is assigned a unique API key, and they can use this API key to submit the attributes in a tool-agnostic manner. And they can submit it from anywhere they like. It's no longer limited to they have to submit it from the login node. They can submit it from the compute node, or they can even submit from their gateway head node. So it's up to them to kind of instrument this reporting the way they see fit. So for example, if a gateway has a kind of a complex system to run jobs on a cluster which is, let's say, freely available right now, then they can manage all this reporting from the head node, that maybe one job runs on Comet, the other one runs on Bridges, and and the gateway can manage the submission, the reporting of it from a central place rather than forking out these things independently elsewhere. So the gateway has control over the design of how they submit the attributes now better than they did earlier. And then of course the API provides feedback on if things are successful or not, or what could be improved. So one troublesome spot was, if you were to submit a gateway attribute for, let's say, Comet, and then under Comet, the Comet compute nodes and Comet GPU nodes are separate resources. So they need to be identified distinctly. And so earlier, if you submitted something, you had to hunt down the correct ID and provide that information through the reporting script. Now all that is a feedback. If you just want to list all the resources that are available, you can just issue a query and say, hey, tell me what resources are available. And you can see which one is the one you want to use, and you can use that to kind of submit the resource, the attributes. And the API now keeps track of which gateway is submitting those attributes. So there is a lineage there. So if in future there is a need for auditing something or looking up something, it can be traced back. This is again more detail on what attributes are there. I'm not going to read the slide, but in principle, the attributes retain the key elements which needed to be there, which is which gateway user is actually initiating the computation, where they were running this job, which is the XSEDE resource name, what is the job ID or the batch scheduler's job ID associated with that, and when was this job submitted. And then we introduced few other things as optional attributes. I'm only going to mention about the software attributes. So we thought that it would be a good idea to allow a capability to let the gateways submit which software they were running for a user's job. And the idea is that over time, we can have some understanding of which softwares are popular and perhaps may require better integration with the software, optimization, and so forth, even though gateways already do this to a certain extent. But now the SPs can also have this visibility on which softwares are being used heavily. There was a software design and a process that was followed through the XCI. And if you are interested in reading the technical details, you're welcome to take a look at that URL. There is a design document, implementation, review, testing, and so forth, which went through a formal process. and that improved several things because of that process. And so here is what a sample submission looks like. So as I mentioned, that the attribute submission is tool agnostic. So here is an example using curl. If you wanted to submit this with wget, you can. Python, same thing. And you can use your tool chain, whatever your gateway is using, to submit these things. Essentially, there are 3 or 4 attributes which are mandatory. The gateway username is mandatory. The XSEDE username is mandatory. The job ID is mandatory, and the submit time is mandatory. The software is optional. So here is an example of specifying a software, which is specified as a generic name, being MATLAB, colon, in a specific name, which is the version. And these need to be specified as the vendor writes them. These should not be made up. So if the MATLAB writes MATLAB in all capitals, one should use that. And if they designate their version like this, then one should use that. Similarly for NumPy is the generic name, and then NumPy version something is the version name. And these should be used as vendor specifies. So we end up with less clutter when we when XDMod starts to compile all this information. And then when the gateway submits this information, it receives a response saying, hey, I submitted this thing, and these were the things I submitted. So the gateways have a good visibility on what happened. So the outcome of this work is there is a new implementation which got rolled out into production just a few weeks back. There's a single place for documentation where the gateways can just go and see what needs to be done. And it's just I think it's just a couple page long, fairly straightforward. We presented a poster at PERC about this work, and our paper didn't make it into the presentation at PERC, but we are told it made it into the proceedings, so it will at some point become available. So the benefit for SPs and XSEDE is that they can now see how the gateways are using a system. They could even see it right now, but now with the better data and consistent data, they have a better understanding of how many gateway users are using the system, how individual gateway users are using their system, and then also be able to see which is the highly used software. Because right now the service providers probably know which softwares gateways are installing, but they don't necessarily know how much each of those softwares are being used. And the gateways obviously know that, but the SPs do not. And once this information becomes available through XDMod, it could be shared with others. That information is public. Other SPs can see it if they wanted to. Sponsors can obviously see it. And of course, the gateways themselves can use the XDMod interface to keep track of things. So for new gateways who do not necessarily have this kind of in-depth reporting built in, they can leverage XDMod now to see if it helps them with at least having a view of what's going on. Gateways obviously were kind of the main focus here, and their benefit is that they have a single place to know how to submit their attributes in a consistent way. There is a single place for documentation. The reporting is tool agnostic, and so forth. So just to kind of give you a quick flashback on...
Amit, can I interrupt for a second? I see a question coming in from Mona.
Sure.
Hi, Amit. You mentioned that a lot of these arguments that's passed in are strings, but you would like them to follow certain formats like the software. What about the list of XSEDE resources? Are there proper strings that we should use for those XSEDE resource field?
Yes, so XSEDE resource names are not made up. There is a authoritative list which one must use. And so on the documentation page, there is an incantation on how you should get those.
Okay, thank you.
You can get the list of, I think there are about 7 or 8 right now which are active. And so you will get an authoritative name and you should use that. Yeah, good question.
Yeah, hi, Amit, this is Chunan. So yeah, software field, yeah, in my case, we have like, for example, which means I'm working on, open topography, for the Kami resource. So software, basically, tau DM is, hydrology shoot, So that's what I'm saying, software like MATLAB and column, MATLAB, something like that. In my case, I try to, express like this. Tau DM, this is the shoot name. Then column means tau DM shoot has a lot of like different type of, application, and then software is there. For example, tau DM shoot column like, pit remove and version 5.35. That's why I just, express like this is software, packaging. So okay. Is there something wrong or?
I think let's take that discussion offline. I think I need to have a follow-up with you. So what Chunhan is saying essentially as well, the software reporting is, is complex. And, we just agree with that. And I think this is optional attribute. We want to capture this information and, it will have some teething problems. And, we like to work with the gateway operators to kind of help them give us the information which we can easily compile. And so it's going to vary on case-by-case basis, but I think this is the general guidance. And then, we can discuss the specific details for each gateways offline. Yeah?
Oh.
Okay.
So, yeah, also another question, gateway user, I think, yeah, how about like the open topography, gateway, you're using like a community account, not like actual real users, That's right. Why, I'm trying to use like just, open, topography community user, So I could not like, put like a real, username because this is not related to XSEDE, user, I think.
Okay, so the confusion is, Chunhan, gateway user is your gateway user. It is not your community account. You must report which gateway user actually has initiated that job. So if it happens to be somebody on your gateway, you already know the gateway user, right? And that needs to.
But this gateway user is actually not real XSEDE users. Is that okay?
That's the whole point. This field is not for XSEDE user field. This is for your internal gateway user. That needs to be specified here. Okay? So if your gateway user is, for example, Mona Wong, you need to report Mona Wong, even though she may not have an XSEDE account.
Mm-hmm.
So that's what this is. This is not the XSEDE user. This is the actual gateway user.
Okay, it doesn't matter. That means like, this is regardless of XSEDE user, we put like a real internal gateway user to put in, right?
Yes, you need to put whoever is your gateway user. That's what needs to go here.
Okay.
And then, you can specify this in multiple ways. You can specify this as their username if they're unique. You can specify this as, if it makes sense, if you have a UUID for a gateway user, you can specify that. But it needs to be, for whatever way you keep track of your users, whatever method you use, you should put that.
Okay. Thank you very much, Amit.
All right, perfect.
Yeah.
I mean, it can even be an email, but this is up to you whether you want to use email handle to put there for a gateway users. I already had this discussion with XDMod. Since this information goes there, they will not publish the emails in the public way. So it's okay to use an email, but if you have other ways to designate and identify your gateway user, you can use that.
Okay.
Let me just chime in real quick. Mona, Amit, how many more slides do you have?
2 more.
Okay, Mona, do you mind if we just finish and then take questions at the end, just because we're a little past the hour?
Sure, go ahead.
Okay, go. All right, go ahead, Amit.
All right. So here is a quick look at what happened in this activity. And I want to say yay. it took, there were a lot of stakeholders in this work, and we did constant consulting with each and every one of them to kind of get to where we are. However, the task is still not fully complete. Now the job begins to shepherd all the gateway operators to switch to the new method. Sorry, there is a typo there. The deadline is November 30. And there are 2 webinars scheduled for the gateway operators for this purpose. One is tomorrow and another one in 2 weeks. And we also want to hand off all this information to XD mod team so they can do a good integration on their side, because once the gateways start reporting, that's when they can start doing the integration on their side. Jetstream issue is still kind of underway. Jetstream has a complex submission mechanism and the way it uses. So on the batch scheduler side, there's a 1-to-1 relationship between the compute job and the gateway job. That breaks in Jetstream because there's a many-to-many relationship. There could be many VMs that could run many gateway jobs. And there are issues with the way current gateway, the way the reporting implementation exists from all parties, from XDCDB to Jetstream to gateway attributes. So there is complexity there. We are trying to sort that out right now. So I wanted to give a shout out to a lot of people who were involved in this effort. I'm not going to go through the list, but there were several people. I wanted to express my thanks for helping out with this thing. Because everyone kind of owns a piece of the puzzle here. So there is a lot of stakeholders in different forms and shapes and sizes, but we needed feedback from them to kind of get to where we are. Well, that's all I have.
Great, thank you, Amit. That really important project will have I think a tremendous impact on XSEDE. So I know we're a little bit after the hour, but I also see from the participant list that we have a bunch of gateway folks on. So for those who want to, we can go over and continue the discussions. If that's fine with you,
I'm happy to stick around.
Okay, yeah. Good. All right, so Mona, you have a question?
Yeah, just to follow up on that gateway user, is there another field to report the gateway user's institution, or can we shove it into that same field?
You should not. There is no need for gateway institution. We just need to know what distinct gateway user is.
Okay. Okay.
I mean, the gateway institution, the gateway already takes care of that, right?
Well, not the gateway institution, but the user's institution, if the gateway knows that information.
There is no need to do that. I think we do not benefit by all that at this time. Yeah, so we wanted to keep the scope of this activity fairly limited. I understand there could be more, but I think at this point, we wanted to keep it, fairly short number of attributes. And, if in future we need to add one more, we will add one more. But for right now, this is the minimal set which we need.
Okay, thanks.
Okay, so
do we have any other questions?
Yeah, so Jay just pointed the publication citation on the chat. So thanks, Jay.
All right. So Amit, I have a quick question and a comment. So first of all, I think it was a great decision that you made this, and with everybody you were working with, that you made this fairly minimalist. That you decided, what is the minimum number of things that are really important to capture. Now, I think that goes a long way. It reduces the complexity, and I think will improve the compliance. And the question I have is, you mentioned software, and that the software should be specified the way the vendor would write it. And I know from talking to the XD mod folks, and maybe you had the same experience, that software is, getting that done uniformly is kind of a mess. And one of the things that the XD mod folks do is they sent me a JSON file where they track things, that they have aliases and regular expressions and so on that they use to make sure that they're grouping the software together properly. Have you talked to them about that?
Yeah, we had a good discussion about this.
Okay.
So I think there is no universal way to do this. At the same time, we wanted to keep it minimal. And, we wanted, I mean, this is the way we want to start, I guess. And I don't think this is a perfect answer there. And again, the software attribute is optional to begin with. And our hope is that we are asking the gateways to report this software, right? And the hope is that the gateways will not change this thing over time. So this is kind of a good, well-defined source set, if you would. We are not asking the XSEDE users to report software, right? Because it's gonna start to show up a.out, a.out, right? So the gateways are, they use a fairly limited number of softwares in their gateways. And so this is one way to do that. Of course, we can have a more, much more, detailed specification. But the XD mod folks, we had the discussion and, we just agreed on this thing.
And the XD mod folks, that they actually do, that they do that on their end. So they'll be receiving, information about jobs where it could be Amber, all caps, Amber, all lowercase. It could be the software package within Amber, like PMEMD, and then they'll do the sorting and grouping at their end. So they don't require they're not requiring that of the service provider.
Okay. So I think here the issue is that if a job used a certain software, the XD mod wouldn't know unless the gateway submitted that, right?
Yeah.
So that's kind of the issue. So in many ways, we are sort of trying to see if we can get a frequency of software use and maybe a wall time which some software consumed, right? In aggregate, right? So let's say Cypress runs Beast, right? How many times does Beast run? How many users use Beast? What is the total wall time? So I think those kind of interesting queries can happen once this information is there.
Yeah, perhaps. And I think Cypress that they
do this. Yeah.
I was going to say Cypress. I think that they put a lot of work into tracking, the usage of individual software and packages. But I think it was a lot of effort. Not all of the gateways have done that.
Right. I think the mature gateways have very sophisticated, reporting mechanism which they developed themselves, but others, new gateways may not necessarily have that. And I think the important piece of the puzzle here is while the gateways have all this information, it's quite a bit of effort for XSEDE or SPs to kind of go and contact each of the gateways and get that information quarter over quarter basis, right? So a central place is a useful place to kind of have at least a minimal set there.
Great, thanks, Amit. Do we have any more questions?
I do have one more question. So ultimately, once the gateways start reporting this and XDMod updates their whatever it is that they need to update, then the gateway should be able to go to XDMod and sort of pull out sort of these stats. Is that sort of the benefit to the gateway on the back end?
Absolutely, yeah. So I think the gateway mod, the XD mod is doing, they are going to be doing all these queries and dashboards and plots and things like that. And so many of these things will kind of, funnel out there as dashboards of different sorts.
Okay, thank you.
Yeah. Thanks, Mona. I think those were good questions.
All right, so if we don't have any more questions, I really want to thank both of our speakers, two very different but interesting, fantastic presentations. So thank you, everyone, and see you all